Today I'm taking another look at my R2000, my Kenwood R2000 receiver, which I restored earlier this year. I'm really pleased with it. It works really well and I use it a lot for shortwave listening, and I hope soon actually to try it with a transmitter as well. But anyway, I wanted to do a couple more things, a couple more modifications, and the main one was to change the mains power socket so that it's switched on the radio instead of being permanently connected as soon as you plug it into the wall. The other thing I've done and I wanted to do was to put a new DC barrel jack in so I can connect a battery or external power supply that bypasses the internal power supply of this radio. And while I was doing that and looking at that, I realized that the previous mains socket had an XY capacitor across the mains leads, and I left that on there when I removed it, and I thought I'd fit a new one. And so I've ordered and got some of those, and I'm about to replace it. So in a moment, if you'd like to see that and have a look inside the receiver and see what I've done to change these main sockets, let's have a look. So here's a rear view of the R2000, and you can see that I've replaced the original socket. Here's the original socket, and this is much bigger. This one has a switch and a fuse. The switch illuminates, which I could show you later. It's quite a bit bigger, so I used a Dremel to cut a slot, and I started with the original slot and cut along using a template. And I used the bits of metal that I cut out to reinforce the gap that I'd made, and also to help strengthen the rear of this new barrel jack I put in, which is for a DC supply, a battery or an external power supply, which bypasses the R2000 PSU. And all this works really well. It means I can see if it's connected to the mains, and I can just turn it off reaching behind it instead of having to find the wall socket. And in a moment, let's take the back cover off, or the bottom cover off rather, and we'll have a look at this switch and see about replacing the XY capacitor. Just finished taking the screws out of the base of the R2000, and I can remove that now. And here's the power supply and the connectors. So let's take a look inside and see what I need to do. So here's the inside of the receiver. You can see how lovely and clean it is following its restoration. Here's the power supply and here's the incoming mains. And I'd forgotten until I took that cover off that I've used spade connectors on these mains terminals. So I'll have to remove those, I think, and solder the wires directly to the switch along with the new capacitor. Now here's the old one across the live and neutral of the mains, and I bought some new ones. Here they are. It's like opening a packet of sweets. Here they are. So I'll remove one of these. So I need to put one of these capacitors across these contacts and hardwire them in. So that shouldn't be too difficult. And so I can also add some heat shrink to insulate it, as it is pretty close to this metal transformer. So I'll get set up now with a soldering iron, get ready to remove those contacts, solder this in and solder the wires in. So I'll be back in a moment. I've removed the spade connectors, I've stripped the wires, live and neutral, and I don't know if you can see in there, I've just slid the capacitor in from underneath and bent the wires across. So I'm going to put them all in together, and I've got my Hakko soldering iron with a fairly big tip, so I can get plenty of heat in fairly quickly and easily. I'm about to solder the neutral wire, and I bent it so it's neatly coming through and it's with the capacitor wire, so I should be able to just do a nice solder joint together. Just need to let this soldering iron heat up, and here we go. Apply the solder, and there we are, a nice neat joint. And just tuck that out of the way. Now I've also reset the red live wire and brought that up from underneath as well, and so now let's give that a nice solder joint too. So now the live and neutral and the capacitor are connected, and I'm just going to trim the leads. It's the live, neutral And I've realised that the heat shrink isn't really going to serve any useful purpose on these contacts. They're miles away from the transformer, but they are a bit of a buffer on the wires between that and anything else. I think the job is now complete. The XY capacitor is across the live in neutral terminals, the switch is in, everything's fine, and you can see the back of the DC barrel jack as well. So I think I can reassemble the radio now and give it a test and make sure everything's okay. So I've plugged the radio in, everything seems to be fine, and you can hear there's some stations coming through. It's very noisy because I only have a loose piece of wire as an antenna. I'm in my garage. I jump to 20 meters. There's plenty of CW. And we'll take a look around the back and see that the light is on, the socket is secure, and it's possible to switch the radio on and off, not only at the front but at the back. So that's a big success. And let's just have a look at how the actual power up works. I'm now going to switch the power on at the back of the receiver, and you can see the lights flashing. If I now press the power button, leave it on clock setting, and then press reset, it stabilizes, and now I can set the clock. And then in future, if I turn the power off, the clock will stay on. And the idea was just to leave the power in to the radio in your shack, and you could have a second clock which you could set to a different time, and then it would always be ready. But I don't want to leave a radio or anything really on standby all the time, so that's why I've put the extra power in the back, which I'm now going to turn off. I've now connected a power plug into the barrel jack I fitted, which goes to the main supply of the radio, bypassing the PSU, so you can use this with a battery or an external power supply. And this is the same size as the connector that's on the QCX Mini and many other pieces of electrical equipment of all kinds. So this is a good strong cable, and I've set the power supply to give 13.8 volts as recommended and at least an amp. And at the moment it's not drawing any current, but if I connect it, you can see the radio's gone into its standby mode and flashing the clock, so it's drawing some current. And now if I turn it on, it takes a little while to boot up. Oh, there we are. You can hear it's working just as well as with the mains. Here are all the contest enthusiasts. So let's just turn that round, take a look at the radio working. Here are all the contesters on a Saturday afternoon. So we can see it's drawing about 3/4 of an amp, so that gives me a good clue as what to prepare if I want to run it with an external power supply or a battery. Although I joked in a previous video that it seemed a bit strange it had a handle on, was designed to be portable, it is actually remarkably portable. And if you're going by car, certainly you could take this somewhere and set it up as a field receiver. Anyway, so that's the test done. I know it works with mains, and I know it works with an external power supply, and I'm happy with my modifications. Okay, so my modifications are complete. I've put a new main socket in. I've been able to put a new jack in for the external power or battery, and everything's working. I'm going to carry on using my radio. I love this receiver. It's going to be a part of my setup, and I'll be back soon with more videos about amateur radio, electronics and other aspects of technology. So thanks for watching.